Okay. So yes, good evening, everyone. Let's start the session. By the time others are joining, let's revise on what we covered in the first class. Now we covered in the first class, why do we need distributed systems, right? So who will answer this? Can someone take an answer and share what are various reasons why we need distributed systems? You have to give me few points. Yes.
There are many benefits: availability, single point of failure, fault tolerance, and performance,
Okay.
security.
So single point of failure. Okay. Great.
Fault tolerance.
Please explain also reason why it helps, how it helps.
Yeah, when we use load balance, right? If any of the node is not working, then the request may be processed by other nodes.
Okay. Okay.
Then
Right.
always the system will be up and running. There will be no downtime.
Great. Great. Yes, absolutely. See, no, load balancer is not required in distributed system. Distributed system means multiple systems are connected together. Yes, but yeah, there is one way of having distribution of load is load balancer. Maybe there may not be there, but even if it's not there, there are multiple systems. There is no single point of failure in distributed architecture. Yes. Next thing is scalability. How it helps in scalability? Anyone?
Based on demand, we can increase the systems.
Yes. Yes, you can number of, so there are always more number of nodes available. So scalability is more in distributed systems because more systems are available for serving requests, right? And you can add more nodes to the system whenever you need more number of users or requests to be served. So a single node system may get overloaded if there are more number of requests, but in distributed systems, you can always have the flexibility to increase number of nodes. That's why you have scalability, right? Okay. Now talk about anything else. Performance. How can distributed system help in improving the performance? Can distributed system be more performing than single node systems?
Yes.
Okay. How?
In our example of TinyURL, we thought of doing there are two service calls. One is a generate token, so generate TinyURL and read in actual URL.
Yes.
If we separate these two methods into two services and we deploy in different systems, then it will.
Yes. Right. Sure.
Yeah.
Definitely. Yes. Right. Correct. You can use multiple nodes to do some computation, right? So in TinyURL, we were doing the same computation in the same server, but even if there is a complicated computation, you can distribute it across multiple nodes and you can parallelize and get it done faster, right? For example, Google search, the entire internet is indexed and it's indexed with the help of many servers. Anytime any pages are changed, some crawler or some node will detect it. It will index the new page, and in real time, if you search for keywords, your search results are updated. So distributed systems are very performing systems, right? Then other benefit is geographic distribution. Okay. What is this? Any idea?
Is it across the world, like availability? Like, for
Yes.
example,
Yes.
back in India, kind of like Europe, how do we handle the load when it is accessed across the world?
Yes, absolutely, absolutely. See, in a single node server, you can be always having it in one location. And if it is hosted in India, then if someone is accessing it from US, there will be some latency because of network delays. But yes, in distributed system, you can serve the request from the servers which are located near to the users. So you will always be able to generate best-in-class experience for the user. So you can make the applications available all across the globe. Yes. What else? Any other points you see from distributed systems?
Fault tolerance.
Yeah, that's correct. Fault tolerance. I would say
Latency, network latency.
is a benefit or a drawback?
Like, it depends on how we design the system, right, to avoid the latencies.
Yes, yes, right. So that's performance anyway, covered around performance. You'll be able, you can reduce the time it takes to complete the task. You can improve the response time by using distributed systems. Yes.
They are very secure, and
Yeah,
parallelism is possible.
yes. So yeah, you have the data replicated in multiple locations and systems are distributed. So they are secure, more secure. And yes, so security is another aspect. And which I would also add here, this is about no single point of failure, right? So this is related point here, security as well, we can put here. Okay, now see, now geographical distribution, what I can do is I can set up two nodes completely independent of each other, right? Say, for example, if I have to create any application which I have to serve in US as well as in India, one approach is I create one single node in India, totally disconnected. It can serve all the users in India. Same time, I can have another instance in US. It can serve all the requests in US. No interconnection between each of them. So this is another way to kind of serve the request. But what is the drawback in this scenario?
In case if there is any failure at one node, so the time it takes to switch to the other one will be more because there is a physical distance between both the nodes.
Okay, okay. Yes, yes, right. So yeah, no, one problem is, okay, single point of failure is there. In India, if the server crashes in India, there is no way to switch. I'm saying they are totally disconnected. We have separately isolated in instances. So in this case, no connection. So yes, you have single point of failure. Okay. Yeah, synchronization also someone responded. That is, again, synchronization adds more complexity. Yes. So it's not a benefits. We are discussing about benefits right now. So what else? See, if I have one server in the India, one in US, assume there's no failure. They are good, reliable instances. I'm taking care of maintenance and all. But yeah, even in the nighttime, the server will not be used because most of the users, the traffic will be very less. Yes. Only in the peak hours, it will be used. So 12 hours, maybe this system is not used that much. In US, maybe there is the traffic, but yeah, their night time, that system will not be used. So there is not proper resource utilization. So with distributed systems, you can achieve better resource utilization. These concepts are important because if you understand them, you'll be able to take better decisions, and you will be able to also convince the interviewer about why you have chosen a particular architecture, right? So this is just a quick recap of what we did in the first class. This is the 5th class. So I just wanted to keep revising things, so which we'll be doing very frequently, so that you don't feel that you are not recalling what we studied in earlier topics, because yes, we will be covering a lot of topics. So now let's go to the point of today's class, which is designing a website which can scale to 1 million users. Right. So here we are designing a website which is designed to scale for 1 million users. Yeah, 1 million users are a lot of users. If you have a website, you can't host it in your laptop or in a single machine. But yes, many websites started as a project. So this is one project, Delicious. Anyone knows about this website?
No, Tarun. I'm listening for the first time.
Okay. This was very popular website. And this was a social bookmarking website. So what do we mean by social bookmarking? Anyone got this? What is social bookmarking?
Yes, Tarun. So if we want to make our website visible, so in that case we are doing social bookmarking, right? So sometime.
Yes, bookmarks are, no, if any website you like, you can bookmark it because you would like to store it as your favorites, and probably you would like to also share it with others. So social bookmarking tool was, this was one site where you can bookmark some websites for yourself, which you want to refer later or you want to revisit again and again. You can bookmark it. And in this website, you can see from your account, all the websites which were bookmarked, right? So this was a very useful bookmarking site at that time, but nowadays browsers are very capable. You can store a lot of bookmarks in your browser, but this is I'm talking about early 2000s. So this website was a college project of a student, but yes, he saw that it is gaining a lot of popularity. People are finding it useful. So he scaled it up to a website or a company. The company also was a multi-million-dollar company it became. So how he curated from a single application, which was running on the laptop, to a very large scale website. This is what we will be covering. We will be also covering what are the technical challenges and how you can scale any website or any application from a small scale, which could be maybe your college project, to scale to a very large application, which can serve up to 1 million users. Yes. So yes, no, maybe more theoretical things you can study from, this is a very popular case study in system design. You can search about it and you'll get a lot of resources, but here we will be focusing on the conceptual part, not about the story behind this particular website, but what are the learnings, what are the architectural concepts which we can discover and use from this site. Yes. So, okay. How would you build a website? Assume you have to build some application, which is social bookmarking application. I gave you the use case. Use case is First is you can create a user. Yes. With your user, you can store websites URL and some short description about the website, right? So maybe you will need plus title and plus short description for the website. Yes. And then you can refer this later and you can share it across also with other users. This is the use case. So basically, what is a bookmark? Bookmark is a website's URL plus, let's say, short description. There may be more fields like tags, etc. Yeah, let's consider them also. So let's say you have the hashtags, right? Because in anything which is social, hashtags are important, right? So yes, hashtag, short description, title. This is all the details which you will be storing, and you can share your bookmarks as well. So how can you build this? What all technologies will you use to build this? Any idea? Anyone would like to take on and then start designing this website? Is the requirement clear? Basically, you need a database where you can store all the bookmarks. You can retrieve the bookmarks by logging in with your username, and you can use these URLs and then you can share it with others also. Yes.
Yeah. So basically we need a website to create the users and
Yes. Right. So what technologies will you use?
can go for React or Angular.
Okay, good. Yes. So you can use React and Angular for front end. Yes.
Yeah,
What
back,
else?
we can use and then yeah, React, Angular, HTML, CSS will come for basically for the front end, and then
Yeah, you can use HTML, JavaScript, CSS as well, and or you can use some React and Angular frameworks also. Yes, great. What else?
and for backend we can use like microservices.
Okay, okay. Yeah.
Spring Boot microservices or Golang.
Maybe we have a bookmark microservice,
Yeah.
right?
Yeah, right.
What all microservices you may need?
Tarun, I have got a doubt. When we are given, let's say, when we are given a question, like, the first thing we decide is upon the technologies, or like last time when you were discussing
Yes.
about the TinyURL, we were telling about the function or functional requirements, like the number of requests,
Yes.
design it like that. So I just want to know if there is right now we are doing finding the, let's say we can do this in Node.js, whatever it is. So is it the right way or is it the structured way that we have to approach a question?
Yes, yes. Now see, this is not we are not approaching system design. Today, our class is more on about understanding how to scale. But yes, just in general, I want to ask, I'm asking you because so that you can figure out what all components are required, right? So in general, the approach is we discuss functional requirements. Yes, but yes, if you see, we are going as per the structure. I already gave you the non-functional requirement. Yes. Now we have to identify the components. Yes. What are the components? So we are just discussing some basics. Like if you have to build a website, what all technologies you will need. We are not attempting this question as a system design interview, but just we are discussing in general some concepts. Right? Great, great question. Nice suggestion or pointing out that yes, probably this is not the approach. We don't talk about the technologies in high level design. Yes, absolutely right. Very nice point. Yes. But yes, I'm just discussing this so that we can identify the components and we can talk about, because here I'm talking about, we are building a website. Assume you are doing this project. You're doing this project in your laptop, and then we will be increasing, we will be scaling it to 1 million users and how it will do. And this is what we are discussing today. Understood? Sounds good?
Yes, sir. Yeah. Okay. Thanks.
Right. Okay. So just don't worry about the approach. Just, I know we are learning today about what are the challenges to scale an application to 1 million users. Yes. So coming back, we have some microservices. Maybe you knew, again, what is microservices? We don't want to discuss. But yes, let's say we don't go with microservices. We can simply build a monolithic app as well, right? So you need some backend logic, some backend server, right? Backend component. Yes, what would be the backend component? What you will use with React or with HTML, JavaScript, CSS?
We can use Node or Java or Golang.
Yes, yes, absolutely. So there are various choices. We already discussed last time that I suggested you with all technologies you can use in TinyURL. So Node.js, if you are a JavaScript developer, Java developer can use Spring Boot, or if you are Python, you can use Flask, or you can use ASP.NET, and there are few other choices as well, right? C++ also we discussed about C++ choices. So there are various ways in which you can achieve this, right? Let's say, yeah, we chose one technology. Let's say Node.js and Spring, we will talk about more. So either of these we choose. What else we need?
A database.
Database.
A database you will need. So let's say we can use MySQL or we can use Postgres, right? SQL. These are open source applications. See, all are open source components. Better, right? As of now, we have used everything free of cost. But yes, there are various other alternatives as well. But yes, this sounds good to start with. Yes.
Yes.
So you can build it, clear, is as a college project. And probably you have to do CRUD operations. You have to design table. Table could be, as I mentioned, there could be bookmark table. And then you have ID for the bookmark, maybe the URL for the bookmark, title for the bookmark. There could be
And we need to,
hashtags.
yeah.
Yes. And
we need user also we need to store, right?
yes, yes. So probably you can store the user or the owner of the bookmark. Yes. Correct. Let's say we do this much, or let's say you may store, or yes, we can store the owner. Yes. And probably you can use a user table as well, where you can use user ID, password. Correct. So this could be one more, and some other detail, username, email, right? Name, etc. You can store. So this is about the database. So simple application, CRUD application. Now, I'm talking about scale it up to more users, right? So assume you created this and it's running successfully in your laptop. What do you think? How many users you will be able to serve with your laptop? First thing is, you have to keep your laptop always running, because if your power goes at home or your battery is drained from your laptop, or you switch off your laptop, the website will become unavailable. So what is the solution? Yes, okay, let's draw this also. So let's call this is client or front end. Yeah, so you will have a front end, which will be web, right? So we will call it web client. Yes. Then in addition, we have also one server. We can call it app server, which could be Node.js or Spring Boot. Yes. And then you have a database. So database, I will draw like this, a server.
Sorry to interrupt
Yes.
here. Sorry, I joined late because of I was having a meeting. So
Okay. Yes.
just
So,
so what we are discussing, like which kind of design or something?
yes. Can someone explain? Yes, please, someone take this initiative and explain him what we are doing.
Yes, Raju. So today we are seeing how to scale a social bookmarking website to 1 million users. So this is the topic we are discussing about. So first we have completed the functional requirement and non-functional requirement and what are the technologies we are using.
Okay.
Yeah. And then we discuss about the database model, like what are the tables we are using and what are the tables should contain. You can see user table and bookmark table.
Okay. Yeah.
So user table contains user ID, username, etc. And bookmark will contain the URL, right? Which user is bookmarking. And if they have any title, we can store that one. And they have some description, right? So we
Yes.
can, we can store that one as well.
Right? Great.
Thank you so much. Thank you so much for explaining.
So yes, initially, let's assume this is running in your laptop. Yeah, this is your laptop or your computer, right? So let's call this laptop or PC. Yes. See, that is a challenging thing, right? So here you have this problem, which I shared, that you have to keep this laptop 24/7 on. Yes. You should connect this to a network, internet also. Your internet connection should always be up 24/7, right? If your internet connection is down, you forgot to pay your bill and your connection got disconnected, your website will become down, right? These are two challenges. What else? How will you expose this website to outside world? You have to share your IP address. Yes, everything is running on one system, right? See. So you have single point of failure. This is another way of saying, because if your laptop any day crashes, right? Maybe something short circuit happen or because of power surges, maybe some chip goes down in your laptop, your business gone, right? So that's single point of failure. Other point is, how will you expose your laptop to the entire internet? Anyone has an idea? How will you do that? Right. So when you are developing something on local host, it's running in local host. So you can access it by yourself by typing probably like this. Sorry, here I'll take this. Local host 8080. Yeah, maybe you name your app, say bookmark. Yeah. And then index.html. This is your page where you will be having this. But yes, how can you access it from outside world?
Yes, we need to buy a domain.
Yes, you need to buy a domain. Okay, perfect. So you have to buy a domain. Let's say you buy a domain, which is in this case, yes, something like this. The guy who did this bought, right? So you have this domain bought, yes, right? Now, what else? So this is your domain. How will you point it to you bought this domain, how will you point it to your local host? Next step.
A DNS resolver.
Yes, you will have to do DNS entry, right? With the purchase of, you will say, if my website is this, it should resolve to an IP address, which is IP address of your laptop. Let's say this is your IP address.
Tarun, I got a doubt there. Let's say, I
Is
mean, like,
this, yeah, correct. Go ahead, go ahead.
if I am doing in my localhost, each time my IP would change, right? So, and I might not be able to purchase a static IP. So, will I be running some scripts for that, or I mean, like,
Yeah, you can't keep updating the DNS entry because DNS entry also takes time to update. Yes, it will take maybe few hours to update, right? Okay.
okay.
So we'll come to that. We'll come to that. But yes, so this is the IP address. Anything wrong in this IP address? Or is it correct? Find out any, there's one, I have done purposely some mistake in IP address. What is that? What is the format of IP address?
It should be 2 digits, right? 10.23.45, something like that.
Yes, yes. So there are 4 numbers which are there in IP address, right? This is the format, right? So you can have 10, you can have any number, right? 4 separated by dots. But yes, what is the range of each of the numbers?
0 to 255.
Yes, absolutely, right? So 0 to 255. So here, the last part is 456 is wrong. Maybe it should be 45 or 145 or 245 or something, right? Assume this is your IP address. But yes, this will keep changing because we use DHCP, right? Anyone knows what is DHCP? DHCP
the
is, yeah, go ahead.
Protocol direct, not direct.
It helps to assign the, like, kind of creates the IP, right?
Yes, yes. Yeah, this is again networking related stuff.
Yeah, high bandwidth digital, some, right?
Yeah, config, sorry, I got this. Right. So dynamic host configuration protocol, this is the way in which IP address is dynamically assigned every time you connect to the internet, right? So with this, you will not get the static IP. So you would need to purchase a static IP with your service provider, right? So which could be Airtel, or they will also charge you extra to get a static IP. But yes, you can check with your service provider, they will provide you static IP addresses, and you should use this. You should have a static IP address and then use it to configure it with your host, right? Instead of doing all this, even there is another way to do that. Or a better way, so that no, you can be little bit better than this. Don't have to purchase the static IP. You have to avoid using static IP. What you can do?
Buy a domain. I mean, like,
okay, buy a hosting place. Okay,
sorry, hosting. Yeah.
right, hosting, or but yes, you need a database as well.
Like kind of cloud service which provided.
Correct. Yes, yes. So other option is, which is nowadays common, you can use AWS, right? AWS, and instead of using your laptop, you use EC2, right? Instances, EC2 instances, what it is just a server which you can host in Amazon cloud, right? This is one option. Right?
Yes.
So basically you will need multiple EC2 instances. One EC2, you will need a database instance also in AWS, and you will need multiple app servers also depending on your load, because EC2 stands for Elastic Cloud. Yes, Elastic Cloud Service. Right. So it's in Elastic Compute Service.
So why we need static IP here and then dynamic host DHCP? Like, I don't know, like, just want to understand that how it is kind of related.
Pardon, just repeat one more time.
No, I'm just trying to say that here you are saying that we have to have a static IP. Static means there will be fixed IP, which let's suppose we got it, right?
Yes.
And now we have DHCP. So what actually it will do? Now it will be applied on static IP and it will generate some dynamic.
No,
right?
DHCP is used when you don't have a static IP.
Okay, got it. So
By
basically,
default, you get DHCP, dynamic IP. Yes. So, but to get a static IP, literally whatever plan you might have seen, your Airtel agent would have given you multiple plan. By this 100 Mbps plan or 200 Mbps plan, 50 Mbps, they have different options, but these are for individuals.
Okay.
We'll also have business plans for some small startups and all. Generally, in these business plans, you get static IP address, right? But
got it.
Inject. And then, but these are more expensive plans. And if you get that static IP, then you can assign it to a DHCP server. That's then you assign to DNS, right? This you can configure with the DNS server.
Okay, so that it will not change and it will be
Yes,
stable.
it will always redirect to this particular IP address whenever someone enters the IP address. Whenever someone enters the address which you purchased, right? Domain registered.
Yes, got it. Yeah.
But yes, instead of doing all this, yes, I would say maybe this is also another option, right?
Okay, so all these three, okay, first dynamic, then static, and
Elastic
AWS.
AWS you can do. So they have done this already for you. So you can get the IP address always, or they have the DNS also. So there is a separate process there with which they can take care of this, right? Basically, again, I am not going into that too much of detail, because how to configure a AWS server with DNS is another topic. Yes. Because again, there is some configuration you have to do in the cloud. But yes, this is one option. I'm just sharing for your information.
Okay.
Yes. But yes, if you do this, then anyway, no problem. Will it scale to that many requests? That's the question. Anyone? Will it scale?
No.
What is the problem?
This is still looks like a single node, right? Or kind of you're not distributing the load across the node.
Okay. Yeah. So let's distribute this, right? So next stage is we will have here some other architecture. How can we distribute? That's what we will be discussing. So first we'll have the client. We'll have load balancer here. You need the load balancer to distribute, right? So load balancer we discussed in the last class, and we may use multiple application servers here. Yes. Is this right? right? I will call AS1, AS2, AS3, right? I'll assume there could be N. Okay. So let's say we use N. Again, depending on what kind of instances you are taking, because there are different sizes of instances which are available. You may take a 64 gigabyte server. You may take 32 gigabyte server, 8 GB server, RAM, and there are also processing capabilities also different in different kinds of server. Assume we chose one and we have this as our application layer, as our business logic layer, and this is your front end. Yes, front end is your HTML, CSS, and then you have the load balancer. Yes, tell me, how will the load balancer distribute the load?
So just want to understand one thing here. So AS1, AS2, whatever we have, it's something like the for bookmark application, what we are talking about, right?
Yeah, these are application servers. Yes.
Yes. Okay.
So
okay.
maybe it is running some code book, yeah, which will be talking to the database. Right. So this is what is your application server, and it will be talking to a database. We'll use a database here. Right. Here database will have some tables. Let's say the database has these tables, which is we discussed. There will be user table, and then there will be bookmark table. Right. Yeah, these are the tables in the database. And hoping that one database is sufficient for this, right? But yes, here probably if assume one machine can serve 1,000 users, let's assume this application server, EC2 instances, they can take care of 1,000 user requests. Okay, let's say 10,000 user requests per second, right? So to get 1 million requests, how many you will need? $100, right?
So is this that one server can handle 10,000 user requests per second?
Yes. One server can per server. Yes.
Yeah, then 1 million divided by this would be like 100.
Right. 1 million, that means 100, right? So you'll need up to 100, n equal to 100.
Okay, so we need 100 server like that, right?
Yes, right. Costly, getting costly.
It's
right?
too costly. Yeah.
Right. So then load balancer also. Yes. Is
Yes.
there load balancer also you will need, but yeah, assume load balancer will be able to handle 1 million requests per second because it is not doing any operation. It is just routing. Right. Yes. The information. But yes, again, there is a bottleneck. Okay. But yes, let's talk about what are the strategies which you can use for load balancer.
Can we also use active and passive load balancer kind of?
Yes, you can use always because yes, this is load balancer can be active and passive. Yeah, you have actually two load balancer, and I would say one is active. And in case active fails, then you can use passive one. You can also have an active configuration. So there are two configurations possible here. One is active. You use both of the load balancers to distribute the load, right?
Yes.
And or you can have active passive also, where one is active, other one is not doing anything, only becomes active when first one fails.
Yes.
Right?
Yes. Yeah.
So this is how you will have to do. And basically what actually happens here is you have a DNS registered, but yes, still you need to purchase a DNS. Yes. So there is a DNS server or whatever is, yes. So probably when user will type in your website, it will get the DNS server, and then you will have some mapping which will be done, and you will get a IP address here, right? And assume this is what they type in till. Yes, so this is the URL they are trying, and this we also discussed how DNS resolution works, right? You will have cache in the browser, you will have cache in your operating system, you will have cache in your router, you will have cache in ISP provider, and then if the address is not available, it will reach out to the domain name servers, which is at the root level. Then root level in this case is .us. Otherwise, it could be .com also or .org, whichever is the case. Then it will get the address of server, which is the domain server. And then you will also get the exact IP address for the complete resolution of the domain name. And then this IP address is what is being used by your server to make a request. Yes. So yes, how will the load balancer balance the load? What are we doing? So I will like to discuss two terms here: vertical scaling and horizontal scaling. See, I am going slow and I am going because I want to make you understand each and every concept. So what is horizontal scaling? What is vertical scaling? Can anyone tell me? No idea?
Scaling is adding of more components into the system, while horizontal scaling is replicating the instances.
Okay.
So, like horizontal versus vertical is that, so let's say if we have a server and then replicating the whole infra, let's say if you have some, a server which is running with 500 GB or let's say 1 TB. So you're replicating
Yes.
the whole server to recreate that instance.
Yes. Yes.
And let's say instead you can like create kind of nodes to or in cloud and all, we create kind of the like container pod to do the same. So that is kind of the other scaling.
Horizontal and vertical. These are the two which we were discussing. I'll tell you, right? So vertical scaling. Let me talk about what do we mean by vertical scaling, right? Assume you have taken a server, yes, and the server has, say, few gigahertz CPU, 8 GB RAM, and 1 or say 100 GB hard disk, right? Nowadays, now everything is solid state drive. Yeah. So hard disk or HSDD, right? Solid state drive. So this is your configuration. Now assume this can serve, say, 1000 user request, or let's say, yeah, 1000 user request per second. Yeah. I want you to increase the capacity to 2000 user per second, right? So what you can do, you can take another server, right? This server. This is a more expensive server. You can have here 2.5 gigahertz. Probably you'll say we'll take 32 GB RAM. And maybe you say now we'll take 1 terabyte solid state drive, right? So probably this will have more capacity. Maybe you will be able to serve more number of users, right? Maybe 5,000 user requests per second. Yes. Again, whatever is available in the market, you can't choose here, or you can also sometimes assemble your own server. But yes, you are making the hardware more expensive. So this is vertical scaling. Understood? So what does it mean is you are basically increasing CPU, RAM, disk, and whatever, etc. The hardware configuration. This is vertical scaling. Now let's talk about horizontal scaling. What you can do is instead, you can take these servers, but yes, you can take more number of such servers. Yes. And you will use this to serve the request. So this is, you may put them in a load balancer and you have the same configuration in all of them. This is also, you buy more servers basically, rather than moving to the other expensive hardware. Yes. Now, what's the difference between these two approaches? Which one is better? In vertical versus horizontal scaling. Here you can up to go to 5,000. But what if I say serve 50,000 user per request per second? So are the hardware available to any configuration? Yes. Or is there a limit? Right. Definitely. The hardware is not upgradable to any extent. You always have the limit, right? Maybe now 4 gigahertz servers are the maximum which you can buy, or 8 CPUs, 8 core CPUs are the maximum, or 16 core CPUs are the maximum which you can buy, right? So you have maybe 8 or 16 core CPU maximum, which is available, and more expensive. These servers becomes very, very expensive, right? But here there is no limit. In horizontal scaling, there is no limit. Yes. So this is the advantage of horizontal scaling. Other problem is still, even if you buy very expensive hardware, it may fail, right? There is always single point of failure. So there is problems in vertical scaling, but yes, horizontal scaling is mostly preferred. Clear why horizontal scaling is preferred?
Yeah.
Great. Okay, Ramesh, you had some questions about ciphers. What are that? Can you explain? So you have written some.
Sorry, it is not a question.
Yes,
so
you were answering to the IP address, right?
Yeah.
Got it. Perfect. Okay. So yes, we will in this case use horizontal scaling. So we have used here horizontal scaling, right? You can do this approach also, buy a better laptop. But yes, already your MacBook would be 1,50,000, and if you buy even a better one, maybe you will buy 2 lakh, 3 lakh. But yes, after that you can't buy a better hardware, maybe you will buy a server, and server may be very expensive. Maybe you can buy up to 10 lakhs or maybe a 1 crore, but then there is always a limit. Yeah, see, if you are buying very expensive hardware, a very big server, enterprise class server, you may spend 1 crore, lot of money, right? And then you have to maintain it well also. So it's very expensive to scale vertically, but horizontally it's cheaper. Maybe you will say, okay, 1 lakh servers, I will buy 10 or 15, 20, 100, right? This is even less expensive for you, and you can use it for multiple purposes.
We can even though like anytime can increase whenever required, right?
Yes, yes, right. You can gradually increase, right?
Yes, but in case of vertical,
Yes,
it's not possible.
otherwise, yes, it's not possible to gradually increase, and you have to do a lot of upfront investment in case of vertical scaling.
Yeah.
Yes. So this is about horizontal versus vertical scaling. You got about the webs. So yes, basically you will need an application server. An application server, definitely you will also be serving HTML, CSS from these application servers, right? So you will need, these are your web servers as well as application servers. Everyone understood the difference between web server and application server? I discussed this in the last class. Yes.
So I've got
Yes.
one doubt. Even with this horizontal scaling, how would we achieve like 1 million requests per? Still, we had like the calculation we had would require 100 servers, right? So
Yes, yes, right. So you would need 100 servers, definitely, no. 1 million requests per second is a lot of requests, right? So you will need 100 servers. But yes, all 1 million user will not be located in one place. Maybe some you will have instances which is geographically distributed. You'll have some servers in Singapore, some servers in India, some servers in Europe, UK, maybe some South Africa, maybe in Latin America, US. You will have in tens of locations these servers, right? 10 servers, maybe you will host all around the world, correct?
I got another doubt. Let's say
Yes.
if this 1 million users is from a single geography. So what is the point of having servers distributed across the world?
No,
Let's say
it's not from single geography. You will not have, your website is, we will
okay.
be working with all the users across the world,
Sure.
right?
Okay.
But yes, it could be possible. Say, for example, WhatsApp may be having these many users. Google search may be having these many, even more users per geography, right? But yes, we'll not talk about that. That we will talk in later examples when we will be discussing system design of WhatsApp, YouTube, Google search. Then we'll discuss. But right now we are discussing only 1 million users all across the world per second, right? Clear?
Yeah, okay, thanks.
Right. So yes, sounds reasonable, right? 10 servers you will have in different data centers. You will get good reliability, all these factors which we discussed. You'll have single point of failure, fault tolerance, security, right? When you have everything like this, yes. So definitely this also means availability, right? You have better availability. Yes, so we got scalability, we got performance, geographic distribution, resource utilization. But see, life is not that simple. You may get good scalability here, but the database will get overloaded. Yes. What to do with the database? Servers you can put behind the load balancer. What will you do with the database? Because everyone is at the end of the day writing bookmarks which is stored in the database. So how to scale the database?
The master slave concept.
Yes, absolutely. You will use the concept of master slave database. What is master slave database? We discussed this in our previous class. Can anyone tell? Yes.
Write will happen to one master node and
It will sync with other
slave node
slave.
will serve as the read.
Absolutely, absolutely. Right. So I'll tell you how does it works. You will have multiple slaves and a master, right? You may have multiple masters also. So basically we'll be using cluster of database where one kind of databases are called master databases, right? This is master databases. Other kind of databases are slave databases. Do we need to sync them, or we can just use a load balancer and then everything is solved? Yeah.
Not required to sync. I think we can use a load balancer. Right?
No, if someone updates the bookmark, what will you do? You need to update all the databases, no?
But if you have master slave, then that will get synced, right? That's, I think, DB properties or something.
No, you have to replicate. Yes. So that's
Okay.
what I was asking. You need replication.
Okay, okay.
Yes. So any changes needs to be replicated here.
So
See,
that has to be done
it's not
manually. you are saying?
automatic. You have to configure or you have to write scripts for replicating the databases.
Okay,
Yes.
got it.
And then when you replicate the data, it will take some time. Yes, it cannot instantly happen. So you have to deal with that. Yes. So this
Yes.
is what master slave configuration you would need here. Right. So basically, if you have the write request will go to master. If there is a read request will go to slave.
So one thing I just want to understand here, as you mentioned, I think earlier in the past sessions, that if master, let's suppose, is getting failed, then one of another slaves can become master, right?
Yes, yes, absolutely.
So how the replication will happen again? Let's suppose the another DB got become master, then because replication is currently happening. Okay, so by default,
All the instances, yeah, replication is happening to all the instances, right? So every
Okay.
database has to have the consistent copy. Otherwise, there is inconsistency. Yes.
okay, so you're saying that, let's suppose as of now D0 DB is the master slave and D1 D2 is the kind of slaves, and D0 got failed.
Yes.
Then I mean, currently replication is happening from D0 to D1 and D2, right? But
Yes.
let's suppose D0 got failed, so now master will become D1. So from D1 to D2, the logic will have that to do replicate. Okay.
Yes,
All right.
yes. You have to take care of that also in case of failure. When you are promoting someone to master, then you have to replicate the changes to all the remaining databases, all the other databases. Right?
Tarun, this is Sam. One quick question.
Yes, yes.
So, what is the advantage of using this master slave database over sharding?
Yes, yes. Right. See, our volume is not that much. Right now. There are two things. So first is number of requests per second. Yes. Other is number of rows or data, which is in KBs per second. Yes. So generally, a data, as I said, database will be able to handle millions of rows. But if you are getting 100 millions of rows, a single database will not be able to handle it. Because the disk which is being managed by the database is having too much of volume, you will run out of the disk space. Yes, and it will take a lot of time for you to index the data. So in that case, you use the sharding. So sharding is another technique where you will have shards. Shards are like other partitions of the database, but yes, they will also have the master slave configuration. Yes, so we are not right now venturing into sharding. Sharding we'll cover later, but you can think of that if the volume have been increased, then you would need sharding also. Master slave configuration will not help because in master you are writing to one instance. But yeah, what if its writing is so much that one database cannot handle, right? Then you use sharding. Got it? So
Okay.
sharding will cover, and will cover in some more advanced use cases where, say, you have too much of data. For example, Twitter, right? Or Facebook. See, everyone is posting every second so many things. Yes. And in that, one approach would be have some shards which are geographic specific, where whatever you are creating in India is stored in India. And if some user is creating some content in US, it is most likely that the content will be used in US. So there will be separate shards, right? But yes, if you are accessing the profile of a friend in a US, then the Facebook servers know that, okay, this content will be in US servers. So they will make a call to the US servers to fetch you the content. That is sharding, right? Sharding is having the same replications available across multiple geographies, or there are multiple copies of the same master slave configurations. So we'll cover sharding later, but yes, currently sharding is out of scope.
So we are using a slave because of there is a two purpose. One is for reading purpose, another is for writing purpose.
Yes, yes. You
So
can
writing
again,
write,
this is read heavy. Yes.
yes.
Bookmark you will create once, but you will access it again and again, maybe 10 times or 50 times. Yeah, if you are sharing, then maybe 100 times you will read, but you will write one time. For every write, you will have 100 reads. So you will use master, which is less, but reads or slaves will be more.
And copy of the slave, right? Let's suppose the read has multiple slaves, the same copy. What is called is a cluster or something, right? Cluster, right? Or
Cluster is everything is the cluster, database cluster, right?
database cluster means, I mean, let's suppose database is there and the same copy we have multiple for that slave, whatever you are highlighting.
Yes.
What we actually call?
Yeah, database cluster is the entire configuration of databases which are acting as a single unit. They are coordinating with each other.
Okay, so entire thing is called cluster here. Entire,
Yes.
all the databases,
The
including
entire
masters,
cluster, right?
including master slaves, including.
Correct.
Okay.
Yes. So if you use MySQL or Postgres, so replication you have to configure by yourself. But yes, some advanced databases, Oracle enterprise versions, and there are some products which also takes care of replication. There are different kinds of replications also. Again, that we will cover once we will be covering the database concepts. But yeah, for now, you just remember that you may need more number of slaves, less number of masters, and you will have master slave configuration. This will get you availability and scalability. Yes. Because now important concept is the application servers are stateless. Okay, so we covered horizontal scaling, vertical scaling. Now another concept is stateless. What do you mean by stateful application or stateless application? Why are you able to load balance? What do you mean by stateless applications? Stateless applications are applications which do not track the history of the request. HTTP is stateless protocol. You should remember that also, right? Whenever you are talking about HTTP, we also call stateless. And stateless applications are scalable applications because they do not store the history. So they can scale to millions of users. If you are tracking the history of all the requests, then you will also need additional storage per user, and you'll not be able to scale to that many users because you need more storage. Yes. So always it's preferred to have a stateless application which do not track history. They take every request as a new request and they do not worry about what was the previous request, and always the response is same irrespective of what was the request previously made. Yes.
But we can kind of, in a stateless application, we can log the information, right? If you want to know that what.
Yeah, you can log the information. Logging
That
is
doesn't makes issues in scalability, right? It will be just
yes, yes, right. So logging does not have any issues in, but yes, in some applications. For example, I'll give an example of UPI application. When you are making some payment using Google Pay, you are entering, say, assume you are paying me 100 rupees. So you will not need to enter my account number, bank details, etc. You can just type in my mobile number. Yes. But in the UPI server, this information is there that my mobile number is associated with what bank account. Right. So here, whenever you are transferring money to any number, this lookup is required, but there are millions of users whose mobile number is associated with different bank accounts. So if you are making transfer frequently to me, every time you are looking up my account number, this is very expensive operation, right? So here, if you have stateless applications, then it may be low performing because it is scalable, because you don't need to store any history. But yes, what if you store that, yes, I have done all the previous transactions with these many users, and anytime there is more transactions to the same users, you can read the information from the previous transactions. Yes. So this way, you will save performance, and here statefulness may help you, right? With respect to performance. So this is difference between statefulness and statelessness. But now there is a problem with this. You have to store this information that my phone number is associated with some mobile number somewhere. Where you will store this? You will store it in data. It's not in database. Database is having all the information. You will store it in application servers. Yes. That means if you have stored my information in application server 2, and next time you call, your request gets routed to application server 3, application server 3 will not have information about my phone number and bank account details. It will have to look up in the database. So in that case, you have to ensure sticky sessions. Yes. So this is another term which I'm introducing, the sticky sessions, right? But yes, otherwise in this kind of application, which is like bookmarking application, we don't need sticky sessions. We can have stateless sessions where sessions do not store any history information. Got it? So yeah, let me know if you have any doubts about stateless.
Can you just like repeat on sticky sessions, please?
Sticky sessions?
Yeah.
Sticky sessions means, assume you made a request. Yeah. So your request will come to the load balancer. Load balancer may distribute the request to any of the server, right? Maybe system, yeah, to here, to here, to here. But if you have a preferred server, that means you are storing some information in some of the servers. Yes, your sessions are not stateless. Then you will need sticky sessions, because that means, yeah, whenever your request will come, it will be directed to application server 3 only. Yes.
Okay, so that means all rest of other servers will not be used that time.
For you, because your information is stored here. So this server can serve you faster.
Okay, got
So
it.
that is the strategy you have used here. This is called sticky sessions.
Okay, so let's suppose if I have requested and my request went to AS2, then
Yes.
it will prefer to come because of this logic sticky session. It will come to AS2 only.
Yes. So yeah, in sticky sessions, the load balancer is configured in such a way that the user's request will stick to same server all the time. Yes.
Okay, but if someone else is requesting, it might go to AS1 or
Yes,
AS2 or
right,
AS3, anything.
So user 1 may be in AS1, user 3 will be in AS3, or maybe different users will be different servers, right? And they will go to the same, because that server will be having the history about it. But this is stateful applications. Yeah. Now also understand the problem with this. It looks easy, yeah, that if the history is there, then yeah, same server is used. But what if that server fails? Yes, it crashes. What will you do in that case? The data will be moved to some other server. Yes, so you need to handle that in case that server fails, either you make that particular user unavailable, right? Then user will be upset. He will not be able to make any further calls, or you handle it by transferring that cache information to some other server and you serve it via some other server. Right? So it adds more complexity.
But again, let's suppose if a user like let's suppose if don't want to store any sticky session for that user, let's suppose AS2, my request goes before and then the sticky session has been stored, but let's suppose it's got crashed and then again I'm coming back, right? So if it is not there, then my request can go to AS1 or AS3 without session, without any previous stored session, right?
Yes, right. Then you will take time, you will get poor experience, right? So that is different strategies you have to handle. But yes, understand that sticky sessions may be used for performance optimization, but they have limitations. They limit the scaling of the application because some storage is required for serving these requests, and some strategy in case the original server where the request has been stored is crashed, then you need to have a strategy to how to deal with that situation. But yes, easier is the stateless session where you store everything in the database. Everyone reads from the database. So even if one server fails, you can very easily switch to any other server And you can add and remove more servers also on the fly, and it will not impact the performance of any users. It will be very seamless experience for all the users. Even if you are adding servers, removing servers, some servers are crashing, etc., users will not notice anything. But in case of a sticky session, they will notice it. Yeah. Because if a server crashes and next time you are requesting, you will see the difference in the performance. Yeah. But yes, always prefer to use stateless sessions wherever possible.
Hello, sir.
Yes, go ahead.
No, actually, could you please give me some example of this stateful application, in our daily life?
Yes. See, stateless applications, all applications which we use are stateless application. HTTP is the example of stateless application. So stateless applications, say for example, when I'm making a call to any website, I am making multiple HTTP requests, and all the requests are giving you the same result. It does not matter what you have previously performed, what operations you have previously performed, right? So these are stateless applications. Stateless application, for one request response, for one request, there is always one response. Stateful applications are applications where for one request, based on history of operations, you may get different responses. Yes. Say when you are searching in Amazon, I will use examples from Amazon all the time. If you are searching in Amazon, assume you search some, say, t-shirt. Yes. This is a stateless request, because whatever you have searched in the past does not influence your search results. Right? I'm not talking about now, there are AI also inbuilt. Some context information is always there. So, but yes, you may get some suggestions, sponsored ads, etc., which is stateful, because these are dependent on your history, but the search results are stateless, correct? You search now, or whether in past you have searched some other thing like car or toy or laptop or mobile phone. When you search t-shirt, you will get one set of results. But shopping cart is a stateful application, because when you add some item to the shopping cart, say assume I added some t-shirts in the shopping cart, I search my shopping cart, I will get a shopping cart with the t-shirt. Now assume I add mobile phone also to the shopping cart. Again, I search the items in the shopping cart, I will get t-shirt and mobile phone. Yes. So it's a stateful application because the result is dependent on my previous operations, right? So if I have added, say, increase the quantity of t-shirt, next time when I search, I will see 2 t-shirts and 1 mobile phone, right? So your all operations in the previous, which you are performing, is getting captured and stored somewhere. This is stateful application. Got it? So most of the time we use stateless applications. Only few times we need stateful applications, right? Because stateless applications are more scalable. Right, so now if suppose one server goes, crashes here, what will happen? We are using stateless applications.
We need to transfer the data to the adjacent server.
No, this is stateless application, right? So we are not talking about stateful application. We are talking about stateless. Will the request go to this server? And if not, why it will not go to this server? So when you call, assume you are visiting a website. There are 100 servers for that website. Say it's a Google search page. Assume one server has crashed. So when you call, why is your request not getting to this particular server? Who's taking care of that?
Load balancer.
Yeah, load balancer. Load balancer is monitoring all the servers. And it will know which servers are available, which servers are not available. And it will not redirect the request to the servers which are not performing well. Yes. So this is the functioning of load balancer. And then once you get a request, this data handling will happen in the database. But yes, you may need a caching also, because the queries may take time. Yes. So you may need a caching layer as well to scale this. Yeah.
So why we need caching for no, okay, for reading you are saying, right?
Yeah, bookmarks. You are storing so many bookmarks. So some bookmarks may be very frequently used, right?
Yeah, but for
So
write
it's always-
also, no, right?
Pardon?
For write operation also we are using caching? No, right?
Writing, you have to write the cache also, right? In case you are updating the bookmark, you have to do both read and write through cache.
Through same cache.
Yes, there will be always one cache, single cache. Yeah. It could be a distributed cache, but the cache is one.
Okay.
Right? So
Tarun, how does the cache process work? I mean, like, how, like, let's take an example of a request and how does the cache work? Can you
let's
explain?
discuss this because this is important, right? So you have a server here. Yes. And it writes to the database. Let me draw a database here. A database I'm drawing like this. So this is the database. Now in between you have cache. Yes. So whenever you are making a call, you will always make a call to the cache. Yes. And whenever the data is there in the cache, you will get the request to the request will come from the cache itself. So database is not coming into picture, right? So database is scalable here. Now you are able to scale the database because all the request is being served from the cache. Only when the data is not available in the cache, you reach to the database to get the data. Yes.
But for a write request, how does the cache know? Like you
Yes.
earlier told the cache, there is only one cache. So for the writing also, we use the same cache. So So that's a question. So this part we are discussing on the reading case, right? So my question is, let's say it's a write request. So
Yes.
how does cache come into picture for that?
Yes, right. Now coming. But yes, you should understand few things here. Cache, I'll discuss each and every detail in depth because very important to understand things thoroughly. Because in the interview, you have to share to the interviewer that you understand it thoroughly. So the drawback here is this is single point of failure. Cache crashes. Yes, this is the disadvantage. Yeah. Okay. And cache, not everything you can cache. So you have to use a cache. And if cache is missed, the data is not there in cache, then there is delay in the response will be delayed. Yeah, if the data is not cache. So there is something called cache eviction, right? Cache eviction policy.
Taran, still the question. I mean, how does cache come into picture?
Yes, yes. I'm coming to the right, but first understand read properly. Yes, because to understand write properly, you need to understand these terms, right? Yes, yes. So just remember this, because yes, your question is something which I'm going to discuss later. So I'm parking your question. I'm discussing other concepts which are required to learn in order to understand the caching first fully. Yeah. Tell me what is expiration policy in caching. This is, yeah.
Maybe the
After
data gets deleted after some time.
Yes, yes. Cache is always, say for example, when you are reading some web page, you may have a cached content, but then if there is new content, you will never see if you don't have the expiry policy. So it's very important in a cache to have an expiry policy, right? It could be 1 hour, it could be 1 day, or it could be it could be different time frames. Yes. So expiry policy is very important. Otherwise, you will be seeing the same data throughout your entire life. Yeah.
Yeah. Yes. Yes.
Then eviction policy. There is something called eviction policy. This is also very important. We discussed one in TinyURL, least recently used. Yes, there is another strategy which is least frequently used. And there is another policy which is first in, first out, right? So these are various eviction policy. This is required because you'll always have cache. Say, for example, if you have, say, 1 GB data.
Okay. So why do we need eviction policy? Because of, let's suppose if must recently use is there, so we'll keep it up. Let's suppose some data is there 100 times which is used, but some data is just one time at the end, right? And that is not being used, so that will get evicted, means that will get actually removed.
Yes, yes.
Okay,
right.
okay.
That's what I'm saying here. If your database is 1 GB, you may have few hundred MB of cache. Yes. You will say, okay, why not use 2 GB data, do 2 GB cache? Not needed. Your data is 1 GB only. So 2 GB cache not required. Cache should be either equal to the database or less than the database. Right? Now you say, okay, why we don't use 1 GB? Let's cache everything. It's very expensive. Right? Cache is expensive because it's a high performing memory, high speed memory. So you will use less, generally 20% of the database is your cache. Yes. And once you fill up all the space, which data to delete is what is decided by the eviction policy.
Yes, got it. Yeah.
Yes. Okay. Now I am coming to the last part, which is consistency. Yes. And this is the right part.
So before that, I just
Yes,
want to understand
yes.
one thing. So eviction policy, that means like who will delete? Is there any separate logic to be required, or it is inbuilt as in cache?
Yes,
Like cache.
in the cache. Yes. You configure the eviction policy and it will be evicted. Yes, the data. So when the new data is written, this is configured in the cache, which will be, so the least recently used, or first in, first out, or whatever is the approach, that approach will be taken care to remove the data. So it will be configurable in cache. Cache can take care of having different eviction policies, and they will automatically take care of removing the data in as per the configuration. Yes.
Yes. Yeah.
Because yeah, these are very standard things. So these will be available in the infrastructure.
So what I do understand that cache will be always like full with 200 or 180
Yes,
MB.
yes, always.
Because data will come as then delete, and then
Yes,
come kind
yes,
of.
absolutely, absolutely, right? So it will always be like, it's a priority queue kind of, right, structure. So you will have a lot of data coming, and at the same time, some data getting removed. So now let's talk about the consistency. This part, consistency, which is the most important part. If you have writes in the database, then cache will be outdated. Yeah. Assume someone has added a bookmark that is also frequently read, so it is cached. But now user has modified the bookmark, maybe added more description or updated the URL. Anything he may do, because he's allowed to modify the bookmarks. Now, it may happen that cache is not consistent, database is having different version of information, cache is having different version of information. So there is inconsistency. If that happens, that's a bug in the application. We should not have, and we should try to avoid such situation. How to avoid this situation is what there are various strategies for avoiding this. And this is avoiding by having the right strategies, right? So one strategy is you do the write only in the cache. Yes. So I will name these strategies. You should know about these strategies. Cache aside, read through, write through, write behind. These are the 4 strategies you should know. Names are self-descriptive. Yes. Right, let's talk about cache aside. Cache aside is you don't consider the cache, you read and write to the database. So this is cache aside policy, right? Because here data staleness will happen. Then other approach is read through cache. Read through cache is what we discussed, that whenever you are reading, you read the cache, and then if the data is not there, then get the data from the database. This is read through strategy. Write through strategy is, now these, first two strategies are anyway more of the strategy which are dealing with reads. Yeah. So can anyone tell difference between cache aside and read through? Are you getting? In read through, you always read through the cache. In cache aside, you read from the cache if the data is available in the cache. Otherwise, you read from the database. But yes, in other case, slight difference is there. You are always reading through the cache. But yes, here write through and write behind is something which is very important, and you should understand these two things.
So what is read through? Can you just explain again, please? No.
What is read through?
Yeah.
Read through is yes. So read through, there is slight difference only, that the difference is in this you read from the cache or you read from the database. Yes. In cache aside, cache is like a side thing which is there to help you, but read through is always you read through cache, right? If the data is not there, you update the cache, then read from the cache. You never read from the database. Yes, so it's very
Okay.
good to put in the picture, but yes, this is the difference.
But
Read through is
you're
you
saying
always
that,
read through the cache.
okay, so if data is not there, then data will be updated. So who will
Yes,
update the
will be
data?
updated first, and then you will read from the cache.
Okay, so who will update the data? That means you are saying that cache will connect further to DB to update, is it?
Yes, yes, right. So cache is intelligent. It will
Okay.
update the data, and then it will serve the information.
Okay.
Basically, yes, here cache is more intelligent. In other case, cache is less intelligence.
Okay, that means read through cannot directly contact with DB, but it will connect with cache, and then I mean,
Yes, yes, right.
everything.
So that's the difference, because yes, in this case, cache is intelligent. In other case, cache is not intelligent. Database and cache together do the reading part, but here cache is taking care of the read through 100% read. He will say, okay, I'll do all the work, but yes, I want to be the main person for doing the read. Database is in the background only. Now, write through and write behind, these are important things. I'll again discuss this with the diagrams, because these two things are what creates a lot of confusion, and this is what you should understand fully. Yes. Let's talk about write through. Write through is very easy. So you have cache, you have server, right? Instead of read, this is now write. So you will write to the cache, and
Cache
cache
will write to
be
DB.
updated. Yes. So what is actually basically, rather than write, I will say update cache. Yes. And then once cache is updated, your database is also updated,
Yeah, yeah.
right? Never problem of out of sync. Yes. You update the cache, you update the database. So you are writing through both the places, but there is a problem. What's the problem? Write operation is taking more time because you have to do this thing first, right? So you have to do this, then you have to do this as well. If one fails, then you will have to revert other, you have to retry, and you have to only, yes, you have to wait for the sync to happen, right? So it's more expensive. So write through has this drawback that writes are slow. Other problem is if there are frequent writes in the cache, your data will also, your database will get bombarded with lots of writes. So yes, if there are writes happening all of the time, database may crash, right? May not be able to handle that many writes. What is the solution? That is right behind is another solution, which is for write heavy, it is used. So I will tell you what is write through. This will be the last topic we will be covering today, which is write through. What is write through, right? Or right behind, sorry. This is write through. Now we are talking about write behind. What you can do is rather than writing to the database, yes, all the time, you can wait. And after some time, write the changes in bulk.
By this way, we can just save and bombarding that DB.
Yes, absolutely, absolutely. Right.
But
Same.
again, there may be sync issues, right? Sync in the sense, I mean, it will be delayed, right? So let's suppose someone is trying to
No,
read.
the only, see, nothing is delayed because read and write is happening from the cache only. Yes.
Okay, got it. So,
If the content is not there in the cache, then it will happen from the database.
Yes, all right,
But
yeah.
there is a problem. There is a problem.
But
What if cache crashes?
crash?
Get fooled, or maybe let's suppose whatever in eviction we have, right?
Yes.
Eviction. And that will actually making everything deleted and everything inserted newly. And there is a delay.
Yes.
So
yes,
that
right.
may happen, but possibility for that is less. And I think if you
Yes,
have more cache
absolutely.
size, then
Yes.
that will not be problem. Like we can have equal to database, then I think that's not a
Correct,
problem.
correct. Right. See, assume you are using Uber app and driver is changing location every 5 seconds. If you use this, there are millions of drivers. Your database is bombarded with so many writes. Yes. But if you use write behind strategy, it will wait and it will write in bulk. So this way you will not have that performance issues. Right. So the last two part is important because yeah, these two things.
But what if the cache crashes before I write to the database.
Yeah, cache crashes, then you lose the data, right? That's a problem. See, always there is trade-offs in system design. You gain something, but yes, in this case, if cache is crashing, you should have a recovery mechanism. Probably, yes, what you can do is you can maintain the cache and have a backup for the cache also, right? So that multiple strategies are here also. One is you keep taking the timestamps and right, keep preserving it, or you can have multiple memories which are being in synced. You replicate the cache, right? You have again multiple caches.
And what if DB will get full if it is beyond 1 GB?
What is database gets full, then you need sharding. Yes.
Right. Yeah, sorry. Yeah.
That's what you need. This is what we will cover later. That is for high data volume applications. Sharding is a technique which is used for high data volume application. If you have many users but very less data, then no need to shard. But yes, if you have a lot of data and a lot of users, then you use sharding. But today what we covered is what we have a lot of users but less amount of data. Less means not that huge amount of data as Facebook or YouTube or any other app like WhatsApp. You can think of these are apps which handles lots of data because you are writing text, you are sharing images, you are sharing videos, lot of things you are doing at the same time. Uber is also very data extensive. Everyone is searching for rides. They are taking the trips. Every 1 second, driver is changing position, changing statuses as well. So these are data intensive or highly data volume application. Yes. So yes, we covered that this is the way we can scale
One question
web
with
application to 1 million
read
users,
through
up to any number of users. Yeah, go ahead.
read through cache. So in the read through cache, when there is a data mismatch in the cache, not cache miss. So data is updated in the database. But in the cache, we have the old data. So how do we, when we always read from the cache, in the read through mechanism, how does cache know the updated data?
Yes. See, in the write through, or which one you are talking about?
Read through.
In the read through. Okay, let me come to that diagram. Okay. Right through, right behind. Yeah, this is read through. Yes.
Okay, so in the read through, whenever we update the database, we update the cache also, is it? In the read through. Is my understanding correct?
No, reading is about reading. Assume writes are not happening here. Yeah.
Okay.
When you have write, you will have write through or write behind.
Okay.
So
Read
what
through is nothing. Read through is nothing, but actually it will read from the cache. And if the data is not
Yes.
there in cache, then cache will connect from
Yes.
database and then it will make available.
Right.
Yeah.
Correct. You can see, you can assume that writes are happening in the database.
Okay, then read through and write through are a combination. If I'm not wrong.
Yes. Yes.
Okay.
Yes. You will use read write approach together, but yes.
So one question there is this. So we'll be using a combination, is what you're telling. Like earlier we were telling we'll use one cache for both read and write. So will that cache be a combination of both these, or I mean, how does it? I mean, or we
No,
use
it will be one of these strategies. See here, read through. Read is what is you are having a strategy for. Write is always directly to the database.
Correct. Yeah. But
Yes.
earlier we
So
were
you
telling
will
like,
get data, stale data. Stale data means inconsistency.
yeah,
Because
that makes
recently,
that,
right, and old data, expiry time is important in that case, because you will only see the correct data after expiry.
yeah, correct. This makes sense. Why? Because like, writing to the database and reading from the cache, that makes sense. But earlier we were
Yes.
telling like, we'll use one cache which we'll use for write and read, right? So this seems to be right, correct?
Yes, yes, absolutely. Yes.
Tarun, hello, sir.
Yes, go ahead.
I have one more doubt, So for
Yes.
example, when we put the data, for example, for the first time, I'm opening this DEL dot something website for the first time, and I'm putting the data, my password username. So in that case, so the data will be first stored into the database or it will directly store into the cache.
In which approach?
Uh, right approach, For the first time, I'm putting the details.
Yes, first time you are putting the details,
Yes.
it will be updated into the, see here again, no. When you are having the details, you will put in the database. And again, depending on what kind of approach you have. If it's write through, you will write in the cache if the cache is vacant, right? And then it will write in the database in write through. If cache is not vacant, since the information is not read, you will not update the cache. Cache will be updated once you have the information read in case of, but yes, in LIFO, last in first out, you may update the cache also. So you will update the cache and update the database also. Right? So you have to use a combination of any of these four techniques, and you have to have the eviction policy also, which could be LRU, LFU, FIFO, and yes. So tell me now, what is your combination? Then appropriately, you will be able to figure out. Right? So in any system design, first thing you have to mention is eviction policy. Second thing which you have to mention is how is you handling consistency, right? What is the approach for write through, read through, whatever. Basically, you will use write through or write behind. These are the two strategy you will use. Other ones are very simple, and these are used only in very simple application. Probably you will not discuss this in system design, but yes, these are the two things you have to always talk about when you are considering caching in your system design application.
Just want to ask you one thing. This write through and write behind and read through, right? These are all the things we can use together, correct?
No, you will not use together. You will use one.
Okay, I mean, either write or either read.
Yes, yes, right? Yes.
Okay, okay.
Because
And
in first two, writing is directly to the database. So you will have the possibility of inconsistency.
okay.
Right? Because you will understand sometimes whether you are doing write through or write behind, you need some complexity, additional complexity. Yes.
And just want to check, eviction policy only applicable for cache, right?
Yes, yes.
Okay.
Where else you think it could be applied? It's for cache only.
database level, it can be applied, but yeah.
Yeah, no, database will store everything. Yes. It will not.
But let's suppose after some record I want to, like,
Correct.
yeah.
Archiving and all. Yes, you can apply that in database also in some situations. Archiving, for example, or you have to assume we need to only store in the database information for 5 years. Yes. In TinyURL also we had the time
Yes,
for which
yeah.
we have to store. So in that case, you can run a background job. Generally, you can run some jobs, right, which can clean the things, or you can have a trigger, which can be event-based trigger, that if some of the records are, you run once a day, a job which scans all the records which are more than 5 years old and then delete it.
Yes.
Right. But yes, we are gradually moving to a simple application to complex ones. Right. So we discussed TinyURL, then we discussed this one, a website for bookmarking. TinyURL was the simplest one. This is slightly more complicated one because yeah, both are, I would say, equally complicated. But yes, gradually we'll move to more complex applications.
Okay, and just want to know, like, the eviction policy is something different than what we cleaning up the database, right? It's not same, because cleaning up the database, let's suppose after 5 years, whatever record is there,
Yes.
we'll clean that. That's not the eviction policy. Basically,
yes,
right?
you don't call eviction in database.
Yeah. Correct.
Yes, because in cache you use the term eviction policy, but in database we don't call it. It is database maintenance, right?
Yes.
You call data archiving if you are moving across two different databases or different locations. Yes, you will. We'll discuss that in later classes where we will be dealing about databases. So yes, this is what we have for today. Clear how to scale and what is the complexity. But yes, see, in system design interviews, you will get more complicated questions than what we have covered till now. Till now is basics. You may get this, or right, either very entry level positions, these questions, or you may get these questions in initial round. But most of the questions which you will be getting in system design interviews are more complex than what we have covered, and we will be, that's why I'm saying that yes, keep attending the sessions very regularly. But yes, this builds up the strong foundation on top of which you can design more complex systems, because yes, foundation is very important. It's good to have more time spent on building the foundation than to jump into more complex topics, because in that manner you may not understand everything. But yeah, if you have a good foundation, then you will gain maximum from all the sessions. Right? So yeah, let me know how much you understood from today's class. 0%, 10%, 20%, you may say 110% also, if you were already knowing more than that, right? So you could say 110, 100, 200 or anything. Yes.
Tarun, I got a doubt. I mean, like, I just want to reconfirm one thing. So in the approach that we discussed today, so we'll be having, let's say, with the 1 million requests, so we'll be having like 100 servers, correct?
Yes.
Okay. And the second question, like the concepts, like, let's say, load balancing or another concepts, different concepts. So we'll go into the concepts in a different class, or?
Yes. Right.
Thanks.
Right. So we will be covering all this in more depth in other system designs, because these are the fundamental concepts. This is what I was talking about. These are the foundation concepts. And most of the topics which we will be covering from here forth will be much more complex than these ones. Yes, so just ensure you are understanding these concepts very thoroughly, because components of system design, the last class was very important, and this class was also very important, because here it is the base for scalability, right? Actually, all 4 classes or all 5 classes which we had were very important, because the CAP theorem we did, fundamentals of distributed systems, that was very important. Then TinyURL and both high level design, low level design, we covered a lot of concepts there. And then the previous class, components of system design, and this class, which is scaling a website to few users to 1 million users. These are all very important. So if possible, revise the recordings also, and share your queries to me over the WhatsApp or through whatever channel you prefer. You may ask in the next class also, and you may ask me over WhatsApp or through other mediums also. Right? So yes, tell me how much you understood from today. Any other questions, queries?
Sir, I have a doubt, but after our friends leave the session, I just want to clarify a few doubts, just small doubts. Okay.
Okay. Sure, go ahead. You can go ahead if no one else has. Yes.
Yeah. Sir, could you please take a, scroll down, go to some blank page,
Okay, sure.
I just want to confirm, please correct me if I am wrong, if I make any mistakes, okay?
Sure.
Just take a client.
Okay, we have a client. Yes.
And we have a cache in between it.
You have a cache.
Yes, cache. And the database below the cache.
Yeah.
So, so my doubt is, for example,
right. See,
I'm the one of the user.
Wait. Just a minute. Let's talk about this. This is yeah. Yes. Right. Yes. Tell me.
Sir, first I will tell my understanding, how I'm thinking about the flow chart.
Yes.
So what I'm thinking is, when the client requests something, for
Yes.
example, let us assume that it's a write, he's
Yes.
putting something.
Yes.
So what I'm thinking is, when he puts something, it will directly go to the database. And from the when we add something into the database, the database will update the cache. So that's what I'm thinking. No, is it the correct way, or I'm making a mistake?
Yes. See, in client, what you have? You have HTML. Yes.
Okay.
JavaScript. Yes.
Okay, sir. Yeah.
So what you do is you call a web service.
Yes.
Right. And this web service, or this is a service which will call the database. So the logic to connect to the database read and write to the database is taken care by some backend code. So your front end is just calling the backend code. Backend code is connecting to the database and calling the database, and eventually the read and write is happening in the database.
Okay.
Right? You will never directly write from client to the database.
Okay.
Yes.
So when we are inputting something, it will first go to the cache. Am I right?
When you are putting anything,
Yes. Yeah.
if you have a write through cache, then it will write through the cache. Otherwise not. Cache is used for reading. So only for write through or write behind, you will have the writing done in the cache. Yes.
Yes, sir.
Otherwise, writing will always go to the database. Caching will only be used for reading.
Yes, sir. So let's talk about this, the reading scenario.
Yes, reading.
So, for example, how to say this? Yeah, I'm putting a URL. Let's discuss about this TinyURL concept. I'm putting some google.com.
Yes.
So I just want to know what happened. So where that google.com will goes, is it directly go to the database or it will first go to the cache?
Yes, it will go to directly to the database if you are. So here, if we are using
Read
through cache or cache side strategy, then it will happen directly to the database. Once you request this, so let's talk about it, right? So first we are saying google.com, right? You have, this is your input.
Yes, I'm doing that input.
Yes, so you are giving input. It will go to the
Read server.
business layer.
Yeah.
It will generate some short URL, right? Say something like this generated.
Yeah.
Yes.
Okay.
There is a table here where we have ID and URL.
Yes.
So here you will be writing this part. This is the ID, and then the URL is this part.
Original URL. Yes.
Yes. Cache is empty.
Yes.
Correct. Now, writing directly done to the database.
Okay.
Now, if you are reading, next thing is someone makes a query, types in this as input, right?
Yes.
So he should get redirected to Google.
Yes.
Cache is empty. See here.
Yes.
He'll try to read to the cache. Cache is empty. So we'll read from the database.
Yes.
We'll get the google.com. And
Yes.
you will get the redirection done to something.
Yeah, no problem. I got it, from database where.
Yes.
Yeah.
But now see, you have read once. So cache will get updated also.
Yeah.
Yes.
Okay.
Because someone has read this, maybe you or anyone, whoever reads it, this gets up because we are using a strategy LRU, least recently used. So all the recently used data should be in the cache.
Okay. So after I understand,
Yes.
Initially the cache is
data
empty.
will keep inserting to the cache until cache is full.
Okay.
Yes. Now the situation is cache is full. You read a new URL.
Yes. Now we can directly check from the cache.
Yeah. But yeah, if you are reading again something new from which is not there in the cache, you can't
then we will
read the cache.
Yes.
But yes, you will read from the database in this case because the cache does not have that information. But yes, after you read, you make sure you delete some least recently used items and insert this one.
Okay,
Correct?
this new one. Yes.
New one, yes. So you have the eviction policy in place.
Yeah, this is yeah, sir. This is I just want to make confirm, whether
Yes.
my thinking is correct or not.
Very good, very good. Yes, this is what I really appreciate. Everyone should do this. Whenever they have the doubt, they should seek for in-depth clarification. Because until unless you don't have this, you will struggle in the system design interview, because when interviewer will ask you these details, you'll not be able to answer it. Yes. So I appreciate this, that you are asking this, and I want everyone should ask such questions and seek for in-depth understanding of all the scenarios. See, I'm using diagram tool and going slowly only for this reason only, that I want you all to understand each and every detail of system design. Great.
Thank you, sir. Now I got clarification how it works.
Yes, yes. And then full clarity you will get. You all will also suggest, also try doing some project also, right? Start investing some time and do some project also. Earlier you start, better it is. So decide on some project and start implementing it.
Sir, regarding this, this TinyURL backend code, can we write in Python creating 3 classes? Is that way we need to do, or is there some other framework to do this backend program coding, logics, everything?
Yeah, Flask. Flask is the framework for Python.
Okay, because I'm very new to the Flask,
Yes.
so should I
Yes.
download some,
Yes, so
some
there is the
installation?
package Flask,
Mhm.
right? Yes, this you can use to write the code. Well, you have to develop a REST service, right? Web service.
Yes, sir. Yeah.
So because normal Python will be used to create command line applications, right? Will not be able to create HTTP server, and you need the backend server code. So which is this, you search, I will give you the URL also for this.
Sir, is there any syntax we need to learn as a prerequisite for this Flask?
Repeat your question.
So is there any prerequisite to learn Flask, some syntax? Is it same as Python or somewhat very different?
Yeah, it's a framework on top of Python. So if you know Python, you can learn this.
Okay.
So this is the URL.
Yeah, thank you, sir. We'll download it and I will try it. Yeah.
Yes, you will find now a lot of tutorials would be there in YouTube and all. If you don't find anything, then let me know. I can give you some good tutorials as so. But yes, as of now, this is the website for Flask, and Flask is the most popular framework for building web services, backend code.
Yes, sir. I got it. Thank you. Thank you so much, sir, for your time.
Okay, awesome.
Good. Yeah, good night, sir.
Sure. Good night. See you. Great. If no further questions, then we can close this session.